Okay, let's try solving a system of equations using substitution. Let's say we're given the two equations, y plus x equals 3 and negative 2x plus y equals 7. Our first step is to solve one of the equations for either variable. I'll choose to solve the top equation, y plus x equals 3 for y. So I'm left with y equals negative x plus 3, simply subtracting x from both sides. We can plug this value for y into our second equation. So instead of negative 2x plus y equals 7, when we replace the y, we are left with negative 2x plus negative x plus 3 equals 7. I simply took this whole solution to y and inserted it here in the equation where the y was. We can then use the distributive property. Positive 1 times negative x, we're left with negative x. Positive 1 times 3, we're left with 3. Sorry. 7, combine like terms on the left. Subtract both sides by 3. And divide by negative 3. Let's do a fancy fraction. Oops. Okay, once we've gotten our x value, we can plug that into either original equation, so we can plug it into y plus x equals 3, or y equals negative x plus 3. Sorry, those aren't the original equations, huh? Like I said, we can plug them into either original equation, y plus x equals 3, or negative 2x plus y equals 7. Or any equivalent derived equation. So we could plug that x into this equation, y equals negative x plus 3, because this was simply derived from the first original equation, y plus x equals 3. I will choose to plug our x value into this equation. Let me rewrite it down below. Y equals negative x plus 3. Plugging in our x, we're left with y equals 4/3 plus 3. Y equals 4 1/3, or let's see, that would be 13/3. So the point at which our two original lines intersect is point x equals negative 4/3 and y equals 13/3.